topic is dielectrics. So first, what is the meaning of dielectrics? Dielectrics are insulators. So it is purely insulators. So what is the purpose of dielectrics in capacitor chapter? So what is our main purpose is here? Dielectrics can be used, or they are providing mechanical strength to the capacitors, as well as by introduction of dielectric between the plates of parallel plate capacitor, our capacity increases. So there are two major role of dielectrics. So one is the role of dielectric in capacitor. Dielectric in capacitor. So first we can say it provides mechanical strength to the capacitor. So what is the meaning of this? Mechanical strength of the capacitor meaning is this, कि when two plates, these are suppose two plates of a capacitor, when these two plates are charged, so one plate is your positively charged, another you are having negative charge. Because of the positive and negative charge, there is force of attraction between the plates. Due to that force of attraction, that plate has tendency to collapse each other. So sometimes it has some plates may bend or some distortion may took place between the plates. So if we are putting a dielectric slab between the plates, and since dielectrics are insulators, so the charge cannot flow from one plate to another plate, being a dielectric insulator. So when we are putting a dielectric slab between the plates, so that charge plates will remain straight, it will not bend like this. So that give you mechanical strength to the capacitor. And second very important purpose of dielectric is that it decreases potential difference between the plates. It decreases potential difference between the plates. So we can increase more energy or more charge in capacitor, or simply we can say as capacitance C is equal to your Q by potential difference between the positively charged plate and negatively charged plate. So Q is the charge on a capacitor plate, and V positive minus V negative means this is the potential difference between positive and negative charge plate. So by introduction of dielectric slab, when we are putting a dielectric slab or insulating slab between the plates, that decreases V value, that decreases potential difference between the capacitor. So when it decreases, C will increase, so we can give more charge, so more energy it can store. So there are two major role of dielectric slab between the plates. One, it provides mechanical strength to the capacitor. Another, its capacity increases. So being a capacity increases, it can store much more amount of energy or much more amount of charge. So now we will see how it works, how the dielectric works. So these dielectrics are made from two different type of atoms. See, some of the dielectrics made from the polar atom, and some of the dielectrics are made from the non-polar atom. So what are the polar atoms? Polar atoms are those atoms which are having certain permanent dipole moment. So how this is possible? In the polar atom, the center of positive charge and the center of negative charge do not coincide. So when the center of positive and negative charge do not coincide, so it has certain permanent dipole moment. So such type of atoms are called polar atoms. And non-polar atoms are the atoms in which center of positive and negative charge coincide, so they don't have any permanent dipole moment. So those type of atoms are called non-polar atoms. So dipole can be, this dielectrics can be made either from polar type of atoms or non-polar atoms. So it doesn't affect much more which type of dielectrics we are using. Suppose if we are using the dielectrics which are made from the polar atoms. So in normal condition, the dipole moment or the atoms are oriented randomly, so that their dipole moment is also oriented randomly, and net dipole moment of a substance of this your dielectric slab will be your 0, like this. See. So we can write dielectrics are made from polar or non-polar atoms. So polar atoms are the atoms which are having permanent dipole moment. And non-polar atoms do not have, and non-polar atoms do not have dipole moment. Okay. So in normal condition, or at room temperature, polar atoms, the dipole moment of polar atoms, is randomly oriented within a substance. So net dipole moment of substance remain 0, like this. See, let this your any dielectric substance, sheet of dielectric substance, and normal temperature. Normal temperature or normal condition means at room temperature nothing has been applied externally. So dipole moment of one atom in this direction. Arrow indicate dipole moment direction. Dipole moment of one atom like this, another atom may be like this, third atom may have like this. In this manner, randomly oriented dipole moments are there. So net dipole moment of a whole system is your 0. It means their dipoles or atoms are not aligned in such a manner that their dipole moment are in a particular direction. But the same type of atoms, if same type of substance are kept in external electric field, then what happened? So as we have earlier read, when a dipole is kept in external electric field, so that dipole experiences a torque. Due to that torque, the dipole will try to align itself along the direction of electric field. So now, when dipole kept in external electric field, then see what will happen. When dipole kept in external electric field, so those dipoles experience torque and align themselves along the direction of electric field, See, like this, same dipole, see, along the direction of electric field. So this is your external electric field. If this is the external electric field, so what will happen? Earlier, dipole moment was oriented randomly here, but due to effect of electric field, this dipole will experience torque and try to align itself in a stable equilibrium position. So when they will try to align itself, then the dipole moment will be directed in the direction of field like this. So these are the just one diagram I have shown here, which indicate orientation of dipole or atom due to the effect of external field like this. Now, if we are further making diagram clearly, then see the diagram. Now, in the initial diagram, when there was no external field was there, so dipoles are oriented randomly, and when external field is there, so dipoles are aligned in the direction of electric field. So aligned dipoles in the direction of electric field. So what we can analyze here, in fact, if we are analyzing this, so what is the meaning of alignment? Alignment means these are the atoms actually. These are the atoms. So this is your one atom, and one atom means dipole moment in this direction, means we can say a negative charge will be somewhere here, because direction of dipole moment is from negative charge to positive charge like this. Then adjacent to this another atom is there, negative charge of this, positive this, then another atom likewise. In this manner we can have dipole moment, and this is the last atom here in that side, negative and positive, and this is the external field. See, if we are looking the one row of atoms, see, due to effect of electric field, this is the orientation of dipoles. So see, positive charge of this atom and negative charge of the adjacent atom, these two charges will come very close to each other, and so these can neutralize. Similarly, positive charge of the second atom and negative charge of the third atom will come very close to each other because of the effect of external field. Why? Because positive charge will experience force in the right side direction, while negative charge will experience force in the left side direction. So these will come very close to each other, and this can be neutralize each other. So here there is a net charge 0, here net charge 0, here net charge 0. So what we will get? We will get a layer of negative charge here, and in this side layer of positive charge, and that layer of negative and positive charge is called polarized charge. So see the final. After that, which type of diagram we can predict here? Like this type of diagram. Due to the effect of external field on this surface, negative charge will appear, and in this surface positive charge appear, and this negative charge and positive charge is called polarized charge. So here QP can be said as a polarized charge, and that charge polarized because of the external field. So let that field your E. Let this is your external field your E. Then what is the effect of this external field and polarized charge? So when charge polarized here, so that polarized charge we can say at one side of the surface negative charge layer, other side of the surface a layer of positive charge. That negative and positive charge layer produces their own field also. So that field will be your, as we know, direction of field always from positive charge to negative charge. So here a field developed which is from positive charge to negative charge, and that field is called field due to polarized charge or polarized field. Field due to polarized charge. So what will happen? To that polarized field you are decreasing the external electric field. So net field. So net field inside the dielectrics will be your external field plus polarized field. Now if, so this is the actual relation. Now if K is a dielectric constant of dielectric medium or dielectric slab, so field decreases by a factor of K. So the net field decreases by a factor K. So E net we can have E by K. So finally we can write E by K is equal to your E plus E polarized. So this gives us polarized field, that is equal to minus of 1 minus 1 by K E. So polarized field is your negative of the me, or we can write in that form, it will be better. EP is your minus E 1 minus 1 by K. It means direction of polarized field your opposite to direction of external field, and this is your 1 minus 1 by K times of the external field. So this is the actual effect of the polarized field. The polarized field decreases the external field. Now if this type of slab kept between the plates of capacitor, then see the effect of that. And now if QP is your polarized charge here and E is the, so let, if E is the field due to charge Q, so E is written as Q by A epsilon naught, and EP is written as QP by A epsilon naught. So that gives us polarized charge is equal to your minus of Q 1 minus 1 by K. So this is the very, very important relation here. The polarized charge is your means negative charge. Negative charge means so Q is the charge which is responsible to get a polarized charge. The polarized charge value will be or sign will be opposite to the charge which is polarizing it. So if positive charge is here, that is producing electric field, so here your negative charge will polarize, and if in this side negative charge is producing the electric field, then positive charge will polarize. So these two are very, very important relation in case of capacitor or in other cases of polarization. Now see the effect of this dielectric and how this dielectric decreases the electric field between the plates, and then how it decreases the potential difference between the plates, then what is the effect on its capacity. See the effect of dielectrics.